Find the angle in radian through which a pendulum swings if its length is 75 centimeter and the tip describes an arc of length. So we have three arcs, 10 centimeters, 15 centimeters, and 21 centimeters. Again, like always, let's start with the circle. So we have our circle here. There is some pendulum that's hanging from here. So, oops, let me draw that. Let's say that's the pendulum, and it's describing some arcs. So, let's say the pendulum starts swinging from here, and eventually it comes to rest here. So, let's say the pendulum starts here and it ends there, and this is the resting position of the pendulum. So further, we're told that the length of the pendulum is 75 centimeters, which means this is 75 centimeters. Okay, now the question is, find the angle in radian. Okay, so we need to find this angle that the pendulum describes. Cool. So we'll plug in these values later on. Now let me just solve in terms of the parameters. Okay, so I'll call the radius r, and then let me call this whole angle as 2 theta. So this small part I would call this theta. Okay, so that this is also theta, and the total angle subtended by the pendulum is 2 theta, and let's call this arc length some L. Okay, now let's try to find the relation between the angle and the arc length and the radius and all that. Okay, at the center of the circle the full angle is 2 pi radians, that we know. Okay, so if the pendulum were to start from this position and go all around and come back to this position, then it would be 2 pi radians. Okay, but it's not actually doing that. What it's doing is it's swinging, right? So it'll swing some, let's say L by 2 on this side, and it'll come back to this side. Okay, so it'll swing back and forth. So that is the total length L, and then we want to find what the angle subtended is. So what we can do is find out how many parts this arc length is of the total circumference. That many parts would the angle be of 2 pi radians, right? So what is the total circumference? Well, if the radius of the circle is r, then the circumference is equal to 2 pi r, whatever the unit, okay, centimeter, meters, whatever it is, that is the circumference, right? So we want to find the value of 2 theta, right? Let's just call it x for simplicity of notation. Okay, so x is the angle subtended at the center. So what is x? Well, x is some n parts of the total 2 pi radians that the circle covers, right? And what is this n? Well, n just represents the number of parts this L is of the total circumference. So how can we find n? Well, n is just equal to L divided by the total circumference, which is 2 pi r, right? So we just plug it in here, and then we get our angle x. Okay, so x is finally equal to L divided by 2 pi r. I just made a substitution, times 2 pi radians. Okay, which is equal to, well, you can cancel pi and pi, 2 and 2, so x is equal to L divided by r radians, which is neat, right? Because now I can just plug in the arc length and the radius, and we get our angle in radians. Okay, so let's just do that. So question 1 says L is 10 centimeters and r is given as 75 centimeters. So for 1, we have angle subtended is equal to L divided by R, which is 10 centimeters divided by 75 centimeters in radians. So that would be what? If you cancel by 5, so this would be 2 by 15 radians. Okay. Next, for the second one, again we have angle subtended is equal to 15 divided by 75 centimeters, and centimeters, they would cancel out, so this is in radians. So this would be what? 1 by 5 radians, right? And finally, for the third one, we have 21 centimeters, so angle subtended would be 21 centimeters divided by 75 centimeters, and it's an angle, so the unit would be radian. And then we get, well, we can cancel by 3, so this is 7 by 25 radians, and that's our answer.